Okay, students, we're now on the third part of this, and this is kind of where we're going to put it all together. So we have one other thing to talk about, and that is the phase shift, and that'll begin to get all the different transformations. So we're talking about a phase shift, so we're now going to be talking about this form for the sine or the cosine. I think that should be a cosine there. Okay, so we're going to focus on what happens when you put this number c in here, like that. So just to review, we learned how to do the amplitude. The amplitude is the number a. The period, the formula is 2 pi over absolute value of b. That changes the period. And then the d is a vertical translation up or down. So I'm going to run through this website that we've been looking at. And this is kind of the standard here. So I want you to watch this. This is a quick review. So if I change the amplitude, that just raises the crest of the waves like this, or it shrinks them. So that's the number in front is changing the amplitude. Okay. We also learned that if this number in front of x inside the function changes the period. So if I make that number bigger than 1, then it shrinks it. The period gets smaller, like that. Okay, we also learned that if you, come on, stop. It's hard to get that thing to stop. Okay, if I take it less than, then it starts stretching. Okay, so when that number gets between 0 and 1, it starts stretching. Okay, so, come on. Okay, there we go. All right, now what's going to happen is we're going to change this number b in here. This is going to cause the phase shift. So notice what happens to my function as I increase this number. Okay, so right now we have phase shifted 0.79 units to the right. You can see how that graph has changed and so forth. The further I move this, further it goes. Okay, that would be a phase shift of pi to the right, so that whole cycle got moved. Okay, similarly, if I do this, if I make b go like this, okay, now what I have is I have a phase shift. If I have a plus there, x plus, then that thing is phase shifted 1.57 or about pi over 2 to the left, like that. So the phase shifts go left and right. So notice plus signs are phase shifting everything to the left, but when we get into the minus signs right now, then they all phase shift to the right. Okay, so that's what I wanted to show you. And we're going to start crunching these things out now. All right, so we're just going to do these graphs. We're kind of done with tables of values, which is kind of nice. So what we're going to do on this problem is we're going to do it really in 2 stages. We're going to start off by just graphing y equals sine of x. Okay, just the basic one. And you want to get to a point where you don't need to look at the unit circle or anything. So what I'm going to have you do is, let's go ahead and get this set up just using standard numbers every 90 degrees. So pi over 2, pi, 3 pi over 2, 2 pi. And also do the negatives. Okay, so these are the numbers you always are going to use if there's no period change. And this problem has no period change because there's nothing in front of the letter x. Okay, the amplitude on this is 1. So we're going to go 1, 2, 3, 4. That'll be 1. 1, 2, 3, 4 down. That'll be negative 1. And that's good enough. So what I'm going to do is just the unit circle. Remember, when we're graphing the sine, we're looking at the y values. So now we're ready to just start learning to graph this. Just remember that a basic sine wave starts at 0, 0, and then it hits its maximum. Then it's back to the x-axis, back to the minimum, or to the minimum, and then back like that. So that would give you one cycle through the sine wave like that. So that's through one period. You can go ahead and extend this to the left. You want to go ahead and just put your points into the left, and that way that'll give us a couple of periods of that. Okay. All right, so here's what you notice. This is what causes the phase shift. Anytime you add or subtract inside the function it's going to phase shift it. So since it's a minus, that takes you to the right pi over 2. And once we get this figured out, I'll explain why that goes to the right too. So really, all in the world you got to do on this problem is this. No tables of values or anything, just start anywhere you want to. I'm going to start here, and I'm going to move this point over here. I'm going to move this point, pi over 2 like that. I'm going to move that point, and I'm going to move that point. So everything is getting moved pi over 2 to the right. So this point moves here, this point moves here, and so forth. All right, and that's our graph. So everything just got moved, again, pi over 2 to the right. Okay, now if we go through and sketch that in, we should have the phase shifted function that looks like that. Okay, like I play music. Of course, I always start these videos a lot of times with a guitar playing. And back in the days when I was in a rock band years ago, you know, I used to have what's called a phase shifter, which just modifies the sound wave and changes the way the sound is. So it's kind of a common thing that guitarists have, and that is actually modifying the sound wave in a similar way to this. Okay, so that would be the final product. Now what I want to show you next is, before we move to the next thing here, just at the side, I want to show you why this works. Okay, so let's start with x equals 0, and then let's go to x equals pi over 2. You can always check by just checking a couple of points. So we're going to plug into the function. So we're going to have y equals sine of 0 minus pi over 2. Then we're going to do y equals sine of pi over 2 minus pi over 2. And this, I think, will show you why everything moves to the right. So if you continue to crunch this out, this would end up being y equals sine of negative pi over 2. Now I want you to look at your unit circle, and negative pi over 2 would be clockwise, so that would be negative 1. So notice that when x is 0, y is negative 1. So if you look at the graph we did, we plotted the point 0, negative 1 right there. Okay, and I'll crunch one more out. If you plug pi over 2 in, you would have sine of 0, and sine of 0 we know is 0. So notice on this, we have a point pi over 2, 0. So, I mean, you can always verify how things are changing by plugging points in. But once you learn that it's a phase shift, then it's very easy to draw that graph. So that's it, okay? All right, so let's move to the next thing, and then example 2 on the next page, we're going to have more things to consider. Okay, pause if you need to process or get anything written down. Okay, so I'm going to move to example 2. And again, what we're going to do on this, the first thing is, it's a good idea to identify everything. So let's start by identifying the amplitude and all that good stuff. All right, so I'm going to just have you do this over at the side. So what is the amplitude? Yeah, the amplitude is the absolute value of that number. So the amplitude is 3. Okay, next thing we want to look at is, what is the phase shift? So which number represents the phase shift? Okay, this one does. All right, so that would be pi over 2, and it would be to the right again. Okay, because of that minus sign. So it's pi over 2 to the right. All right, so we've got the phase shift figured out there. The next thing I want to pay attention to is, what does that do? So what does that number do? That's a vertical translation, so you would just say that is taking you down 1 unit. So we're going to modify a basic cosine wave in these ways. And again, we can do this in a couple of steps. You can even learn how to do it in 1 step. So that's what I want to try to demonstrate. So the first thing we're going to do is, we're going to graph just y equals cosine of x. I'm just going to worry about that. All right, and I'll show you kind of the order that you do these transformations. So again, on a cosine, we just look at the x values, okay? And we don't have a period change. There's no number in front of x, so there's no period change. So that means we use standard points. That means the period is 2 pi. So we just go by 90-degree increments at any time that happens. So we're going to go ahead and set this up. So go ahead and get your x scale figured out. So we're going to go pi over 2, pi, 3 pi over 2, 2 pi, and then also do the negatives. Okay, and then the other thing is the amplitude and vertical translation tell you a lot about how you should set up this y scale. So I always kind of look at it like this. If you have an amplitude of 3, that would mean you have a max of 3 and a min of -3. However, since you're going down 1, the new max is going to be 2, and the new min is going to be -4. So that means we need to make our graph go down to -4 to be able to fit all the points in. So that's going to be -4, and we only really have to go up to 2 on the y-axis, like that. So you want to know how to look at your function and tell what the max and min are. Okay? All right, now we're going to go ahead and plot our points so you can go to the cosine. So when x is 0, the cosine is 1. X is pi over 2. The cosine value is 0, and so forth. Then it goes to -1, back to 0, back to 1. Okay, that's your cycle of 5 key points on the basic cosine wave. The quicker you get that memorized, the faster you can do these graphs. Okay, then just cycle through on the left and just put your points in. And then this way we're going through a graph using 2 periods like that. Okay, so that is the cosine wave. Now the order you want to do this in is like this. The first thing that you always want to do, and I can't emphasize this enough, is you have to do these transformations in a certain order. The first thing that you always want to look at is kind of work inside out. So we want to do just this part right here first, just that phase shift. All right? So we're going to go ahead and do this in 2 stages, and I think that would be, you probably follow that better. So the first thing is, the second stage is I'm going to graph, and I'll pick another color. Come on, erase. Okay, pick this color, and I'll pick green, and we're going to graph y equals cosine x minus pi over 2. So you want to start at the phase shift if you have one. All right, period change and phase shift is the first thing you always focus on. So just move all of these points pi over 2 to the right. It doesn't matter where you start. If you want to start here and move this point, that point is going to move to there. Okay, this point is going to move there, and so forth. And then once you get a couple of points, then it's easy to get the rest of them. Okay, and then you can just start kind of predicting where they go. So it's going to show that you've got the phase shift like that, and then cycle backwards through those points like that. So every point is just simply getting moved pi over 2 to the left. All right, so that's how that goes. I'll zoom on this just a little bit so I can see this a little bit better. Okay. Okay, so far so good. Okay, now the last step we're going to do, after we've done the elementary function, and I'll pick a final color like orange or something. So now we're going to look at the 3 and the -1. So what this does, that changes the amplitude and takes you down 1. So what you're going to do is 3 times the y value in the previous stage minus 1. Okay, and I'll crunch this out as we go. You start learning to do this in your head. So I want you to focus on the green graph and focus on just these points right here. Okay, focus on their y values. So what we're going to do then is we're going to just do a little number crunching like this. Okay, so let's start. That's y equals 0. So we have 3 times 0 minus 1. That is -1. So this point right here moves to -1. That's where my dot goes. The second point has a y value of 1, so you do 3 times 1 minus 1. So that's 3 minus 1, so that's 2. So this second point here now has a y value of 2. So we're kind of stretching the amplitude and moving down at the same time. The third point has a y value of 0. So 3 times 0 minus 1 is back to negative 1. So the third point moves there. The fourth point has a y value of negative 1, so we do 3 times negative 1 minus 1. That's your minimum of negative 4. So that point moves there. Okay, the last point is back to a y value of 0. We have already done that a couple of times, so that gives negative 1. So that point moves there. So again, study what I did on this. So what I did is I just took the y values of each point that we did on step 1, and I did 3 times that value minus 1. The 3 and 1 are affecting y values. Now when you go through and plot this out, then you got one period of your function right here. So then I can go through, and that will be the final wave right there. And then you can back up and you can do another period if you want to. So notice if you go to the left, it would be ready to hit the min. Then it would be ready to hit the midpoint. Then ready to hit the max, and so forth like that. So once you get one period drawn in, then it's really simple to get the rest. So that would be your graph through 2 periods. Okay, I'm going to try to close off a lot of these problems by checking. And when you check, just pick a couple of points and pick x values. So you're going to pick x values on your graph. It doesn't matter. I like 0. I'm going to pick x equals 0. And I'm going to pick x equals pi over 2. And plug into the entire function. This entire thing right here. God, come on. Work. Okay, that entire thing right there is what we're going to do. Okay, so just plug in and check. So let's plug in a 0 here. So we would have 3 cosine 0 minus pi over 2 minus 1. Just look up negative pi over 2. The cosine of negative pi over 2, if you look on the unit circle, is 0. And then 0 minus 1 gives negative 1. Okay, so look at this and make sure this point is on your graph. Okay, so we got 0, negative 1. Look at this point right here. So notice that in our final graph, we have that point 0, negative 1, so that checks. By doing pi over 2, you do the same thing. Plug pi over 2 in, so you'd have 3 cosine, pi over 2 minus pi over 2 minus 1. So that's 3 cosine 0 minus 1. Cosine 0 is 1, so 3 times 1 minus 1 is 2. So let's see if you've got the point pi over 2, 2 on the graph. Okay, notice you do. Pi over 2, 2. So that point right there is pi over 2, 2. Therefore, it checks. Okay, and it doesn't take very long to check, and I wish students would do that because that's how you tell if you're right. And you might as well do that, and all you got to do is probably check 2 points, and if they're right, you're probably, the rest of them are probably right if you know what you're doing. Okay? All right, very good. So that's how you do that. We're now starting to put all of these transformations together. Okay, so the next thing I'm going to take a look at is just looking at these 2 things and finding all the details of that. Okay, so let's take a look at this. I'm cooking up some stew right now, so I got to pause every now and then and check on it. Man, it smells good. It's a cold day outside too. Should be perfect for dinner. All right, so let's go kind of look at these things. And first of all, we know the amplitude on this one is 1/4. You don't have to put that absolute value all the time, but just remember it's a positive number. Okay, so we've got the amplitude. Okay, when we do the period, we're going to use the formula 2 pi over b. Okay, so we want to do that, 2 pi over absolute value of b. Okay, b is the number in front of x, so b is just 1. So we'd have 2 pi over 1. Therefore, the period is 2 pi. Okay? Next thing is the increment of the x-axis. The formula I taught you on that is period over 4. So the period is 2 pi. 2 pi over 4 reduces to pi over 2. So what that means is if you were graphing this function, what you would do on the x-axis is you would do this. God, these things aren't working today. God. So the x-axis would be incremented like this. It would be 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, and of course that would reduce to pi, and that would reduce to 2 pi. So that's kind of the standard increment. Okay, the phase shift we learned is this number here. Work. Okay, so that would be pi over 2, and that's a plus, so it would go to the left. So we would say on the phase shift, we would say negative pi over 2 to the left. We use the negative because it's phase shifting to the left. Okay. Okay, vertical translation is the 10. Okay, so vertical translation we're going to say is just say up 10 like that. Okay. God, I wish this thing would work. God dang. Let me close OneNote and reopen it real quick. OneNote just one of the buggiest programs I've ever seen in my life. Concept's great, but man, it's got bugs all over the place in it. I can feel those bugs crawling every time I use it. All right, so here's what you do next. All right, so the amplitude tells you about these maximums. If the amplitude is 1/4, then that means you're going to have a max of 1/4, and then you're going to have a minimum of negative 1/4. However, you got the plus 10. So that's going to shift up 10 and minus 10 to give those values. So this would be, if you used a calculator, you can, that'd be 10.25. So that would be your maximum. And then this would be negative 11 point, no, Brad, come on, negative 10.5.
Why do you think he said that?
Man. Shoot. So negative 10.5 is what you would have there. All right. So plus 10. Hold on, Brad. Gosh. I'm getting frustrated because this OneNote's driving me up the freaking wall. So you add 10, okay? Okay, so add 10 there, and then that would give 9.75. I knew I was doing that wrong. Okay, so just get those things recorded. And then we got everything we need there. Dang, this thing's driving me nuts. Okay, so we got that. All right, well, the midline is just the average of these two numbers here. So if you want to find the midpoint between the maximum y and the minimum y, you go like this. You just you subtract those two, 10.25 minus 9.75. You should do the absolute value and then divide by 2. Okay, and you can certainly use your calculator if you want to on that. So that would end up being, it looks like 0.5 divided by 2, so that would be 0.75, like that. And then we can add that, and I'll show you what to do in just a minute. I need to do something out here. Okay, so then if you work that out, you're going to end up with 0.5 divided by 2 is 0.25. So it's really just half the distance between those two numbers, but then you want to add it or subtract it from the biggest one. So the midline, I'm just going to take the max, 10.25, and subtract 2.5 or 0.25. So the midline you would get on this is y equals 10. Okay, and you can do that a lot of times in your head. It's just what number is halfway in the middle of 10.25 and 9.75? That's 10. Okay, so that would give all the pieces of that problem then. Okay, now I'm going to go to this next one, and what we want to do with this is, the first thing is, this is not in a factored form. You're always looking for a factored form like this. You always want to have y equals the amplitude. If it's a cosine, you'd have cosine b parentheses x minus c plus d. This is not in a factored form, so we have to factor it, okay? So I'm just going to kind of do this down here. So what we'll have is just focus on this part of the problem right here. Okay, just that. So if I have cosine of 2x minus pi, I have to factor that 2 out like this. So I have cosine, and then I put a bracket, and then 2x parenthesis. Then you got to figure out what goes inside, like this then. Okay? All right, so it goes like this. Just take this number pi and divide it by 2 because you took that out. Then that's the factored form. Really, you always just take that number divided by that number and get that. Now distribute in your head. See, 2 times x and then 2 times pi over 2 gives you 2x minus pi, and that's what the problem started with anyway. So the factored form is going to be y equals negative cosine bracket 2x minus pi over 2 minus 5. Okay, so that is our factored form, and that's important to do that because you can't figure out the phase shift unless you put that in a factored form. So if it's not in a factored form, always do that. Okay, now what I'm going to do is just kind of finish this up. The amplitude would be just 1. The period would be 2 pi over b. B in this problem is the number in front of x, so that's 2. So that would be 2 pi over 2. So that is pi. The increment is the period divided by 4. So the period's pi. So you'd have pi over 4. Okay, so you want to be able to get those things efficiently. And then the increment, just again to kind of remind you, the increment just means on the x-axis you would just go 0, pi over 4, 2 pi over 4, and etc. like that. That's how you do the x-axis. Now the phase shift, pay particularly close attention to this. The phase shift is this number. It's not that number because that's not in a factored form. So that phase shift is pi over 2 to the right. That's why you got to put that in a factored form. All right. You end up just taking that pi over 2 to get that, but the factored form is what you want to develop the habit of. Okay. All right. So we got the phase shift. Okay. The vertical translation, of course, is the 5. So that would be down 5. Okay, the minimum and max go like this. Okay, so since the amplitude's 1, the amplitude always kind of tells you how to do this. If the amplitude's 1, then the max starts at 1 and the min is at -1. But since you're going down 5, then those values change. So the max would be at -4 and the minimum would be at -6. Now one thing I want you to notice on this is the distance between those two numbers is 2. Those two numbers are 2 apart. Well, if you take half of that, you get 1, and that's what the amplitude is. All right? So the midline, you can do this one in your head. What's the number that's directly halfway in the middle of -4 and -6? And you can do an average on this if you want to. You can just say -4 minus 6 over 2. So that's -10 over 2, so that is y equals -5. That's a better way to do that, is just do an average between those values. Okay, so we're kind of now beginning to put this all together. You need to be able to look at a function, put it in factored form, and then quickly find amplitude, period, increment, phase shift, Up, down, max, min, midline. All those things are very important. Okay, so I'm going to scoot to the next page. Okay, and then I'm going to put you to work on two problems. Okay, so I want you to graph this. Now, this one, I keep making this mistake on this handout. I'm wanting you to do a cosine of x. So what I want you to do is graph the cosine and then graph this final product like this. I have a unit circle over the side if you need to refer to that. Just give this your best shot. See how it goes. Come back and check. When you're done, it's probably a good idea to check 2 points on your final graph and see if they're right. Okay, so I'm going to go ahead and I want you to look at what you did, and I'll kind of talk through that first one, and then we'll go to the next page and I'll let you check the next ones. Okay, so the first thing that you want to do is identify everything. That's real important. The amplitude, of course, is 2. This is already in a factored form, so the phase shift is this number. So that is 3 pi over 2 to the left. So since it's going to the left, you like to say that it's negative 3 pi over 2 for the phase shift. Vertical translation's up 3. The period, basically b is 1, so the formula is 2 pi over b. So the period's 2 pi. Increment, you do 2 pi over 4 to get pi over 2. So the way to start this then is, since my increment is pi over 2, then I went ahead and just counted out pi over 2, pi, 3 pi over 2, and so forth on the x-axis. Okay, and then the y-axis, since we have an amplitude of 2 and we're moving everything up 3, well, okay, 2 plus 3 is 5, so that maximum is going to be 5, like that. Now, I did this primarily in 3 stages, so you can kind of check what I did over here if you want to. So I graphed the cosine. Okay, the cosine, you can check those points there, has y values of 1, 0, negative 1, 0, 1. So that's the graph of the cosine that I have in red. Then I phase shifted. So you have to look at my graph and see kind of what I've done on this is, I'm going to zoom on this just for a second here. So what I did was I picked a point, like I decided to start with this point here, and I move there. So every point really goes 1, 2, 3 units over based on my scale. So that goes there, and see, that's good enough for me. Once I know where the max of the cosine is, then I know how they're going to cycle through those key points, see. That's the max, so it just goes x-intercept, min, x-intercept, max, and so forth like that. So once you phase shift 1 point, then you're generally in pretty good shape. Okay, now what I did from here is, what you do is I highlighted these points here in yellow. All right, and what I'm going to do is I'm going to translate these y values by multiplying by 2 and adding 3. So the 2 is changing the amplitude, the plus 3 is doing the vertical translation. So look at these y values, 0, 1, 0, negative 1, 0. That's what I wrote down right here, and I just multiplied by 2 and added 3. So I got 3, 5, 3, 1, and 3. So that gives the y values of those points then. So if x is 0, then that had a y value of 3. Then it went to a y value of 5, then to 3, then to 1 to 3, and so forth like that. So what I'm doing is I'm just basically taking the phase shift, and then after I do that, I'm affecting the y values. So that's it, all right? Pause if you need to pause on that then and kind of think through that. The next thing I want you to check is what you did here and see if you're on the right track here. So this example, 2.5 is the amplitude. It's in a factored form, see? So the period would be 2 pi over 3. The phase shift would be 4 pi to the right. The increment would be the period, 2 pi over 3 times a fourth. So that would be 2 pi over 12. That reduces to pi over 6. So that would mean that if you did your x-axis, you would just go like this. You just count pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 as far as you want to go. All right. Okay, the vertical translation's up 1. And then again, the way you get the max is look at the amplitude. The amplitude is 2.5. So before you vertically translate, you would go from negative 2.5 to 2.5. So just add 1 because of the vertical translation. So 2.5 plus 1 gives you a max of 3.5. Negative 2.5 gives you negative 1.5. Then it's mainly just a matter of finding the average of these numbers. So when you average two numbers, add and divide by 2. So you should have got y equals 1 for your midpoint like that then, or your midline. Okay, next one, make sure you did the factored form. You got to factor the 1/2 out. And when you do that, you'd have 1/2 x minus 8. And see, what you're doing is you're taking that 4 and dividing it by 1/2. But that's 4 times 2, so that's 8. You divide fractions by multiplying by the reciprocal. Okay, the amplitude's 1. That's the number in front of the cosine. The period is 2 pi over b. b is 1/2. So 2 pi times 1/2 is 2 pi times 2, so that's 4 pi. The increment, take the period 4 pi and divide by 4 to get pi. Phase shift is 8 to the right. Vertical is down 8. Okay. The maximum value, remember, if your amplitude is 1, which it is, then the max would go, you would go 1 to negative 1. And then since you're going down 8, just do that, subtract 8 to get negative 7 and negative 9. And one thing I want you to notice on this too is these two numbers are 2 apart. And remember, the amplitude is half of that distance. So the amplitude would be 2 over 2, so it would be 1. Once you get the max and min, just make sure they satisfy the condition of the amplitude. Then the midline is just halfway in the middle, so that's y equals negative 8. Okay, so pause this if you need to. So the graphs are now getting a little bit more advanced, so we got really one more step to put together, and then we've learned everything we need to know about the graphs essentially. Okay, so moving down the next page, you're going to work a little bit more with a problem now where we're putting it absolutely all together. Okay, so we want to do this in as few steps as possible. So first of all, it's a cosine, so the first thing we're going to do, I'm not even going to graph the cosine. What I'm going to do is kind of have you work inside out. So actually what I mean by that is you can learn to do these problems in 2 steps pretty easily. That's the inside part, and that's the part that affects the x's. Okay, so we're just going to focus on that part right now. All right, and get that done. So first of all, let's identify everything on here when we graph this and everything. So the period, it's in a factored form. So we would do 2 pi over absolute value of b. So that's 2 pi over 2. So it has a period of pi. Okay, the increment would be the period over 4. So that's pi over 4. So that's going to tell you how we need to do the x-axis. And then the phase shift is pi over 4 to the right. Okay, so we're just going to focus on that. Not going to worry about amplitude and vertical translation and reflection until next. Since we have an increment of pi over 4, then just start counting by it. So pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4, and then I'm going to even go one more, and then go 5 pi over 4. Okay, and reduce the fractions as you go. So let's get it set up. We have pi over 4, pi over 2, 3 pi over 4, pi, and then I'm going to take it out one more because of the phase shift, 5 pi over 4 like that. Okay, I'm only going to do one period on this. You can go backwards if you want to, but this one I'm just going to kind of focus on doing one period and getting that done. Okay, all right, so we're going to focus just on graphing this only. So we're focused on graphing y as cosine 2 x minus pi over 4 and just that. Okay, so think in your mind how a cosine goes. A cosine at 0 is equal to 1. But we're not going to start this here. We're going to, that point right there is going to phase shift. Since we're phase shifting pi over 4, the cosine wave is going to start here. If you have a phase shift, you ought to start there. Remember, a cosine starts at the high point, then it cycles. Now, see, the rest of this you can do. You know that after the high point, it reaches the x-axis, then it hits its min. It goes like that. So that would be the graph of this thing right here. That's all you got to do that graph. Okay, the idea was the cosine starts here, but we phase shifted it. Okay, so I'm just really phase shifting all of those points on the cosine to the right is what I'm doing. Okay, right? Now, what we want to do from here is we're going to now do the amplitude and that kind of stuff all together. Okay? All right. So the second stage is what we're going to do is we're going to multiply the y values on here by -3 and add 2. So -3 times the y plus 2. So we're going to transform those 5 key points that we've already done like this. Okay, so I'm going to highlight these points, and let's look at the y values of each of those points, and those points we've already got the phase shift and period taken care of. The period came from changing that increment and how we label the x-axis, see? Okay, so let's put these y values in. We have a y value of 1 here, then 0, then -1, then 0, then 1. Crunch out the details in your head. So this would be -3 plus 2 is -1. This would be 0 plus 2 is 2. This would be 3 plus 2 is 5. This would be 0 plus 2 or 2. And -3 plus 1 would be -1. So what I do now is I just change those points and I'm done. Okay. So this point now has a y value of -1. So move it. Next point has a y value of 2. Next one has a y value of 5. So it'll be up here. And then back to 2. Then back to -1. Okay, I should have labeled my y-axis, so I'm just going 2, 3, 4, 5 like that. That's it. Okay, we are done with the problem. See, you can get to a point when you start putting this all together that you can do these pretty easily. So those are your 5 key points, and you don't need to do another period unless you want to. So you would have that. There's a couple of things that are kind of worth checking on this. I always recommend that you check a couple of points. So let's do that. Let's use x equals pi over 4. And then let's use x equals pi over 2. Now when you check your point, you want to plug it into the entire function. So you're kind of checking the whole thing as you go. All right, so I'd like you to write these down, these 2 checks. You can check more if you want to. So we would have y equals -3. Oh, come on. God. Okay, -3 times the cosine of 2 times pi over 4 minus pi over 4 plus 2. Okay, so let's just check out the details of that point and see if that gives the right thing. All right, so if we finish this up, okay, it's going to go like this. We have -3 cosine. See, this whole thing here becomes 0, so it would really be cosine of 0 plus 2. The cosine of 0 is 1 on the unit circle, so that would be -3 times 1 plus 2. See, that's what we did here anyway, see? So that's right. Okay, and you can check another point if you want to. I don't know, I'm just going to check 1, but you can check another one if you want to. That's it, the problem's done. So notice what I did is I worked inside out. So you want to do the inside part first, where you work with the phase shift and period change. Then the next thing is just do the amplitude and the vertical shift. And see, everything happened on this problem we expected. You can see the amplitudes changed. You can see it's been phase shifted. You can also see it's been reflected. So like this minimum here turned into a max. So that -3 caused that to reflect. Okay, so I'm going to move to the next page, and I'm going to do one more, and then I'll probably let you do one, and then that'll close this part of the video off, and then we got one more part of this to look at. Okay, so now we're trying to get to a point where we can do these fairly quickly. So what I'm going to do on this one, first of all, is we're going to put this in a factored form. So you want to pull that 1/2 out. So I'm just going to kind of focus on this part right here over at the side. You can learn to do this in your head. Whatever's in front of x has to be factored out. So you would end up having cosine bracket 1/2 x minus, and what goes here is pi divided by that. And be careful about that. You're dividing by 1/2, so that's the same as multiplying by 2, so you'd have 2 pi. Check it out and see if it works. See, this is, when you distribute, that's 1/2 x. And then if you do 1/2 of 2 pi, well, you're back to pi. So do the distributive property to check. Okay, so what we're going to have in our factored form is we're going to have y equals 1/2 cosine bracket 1/2 x minus 2 pi. Okay, then minus 1. And what we're going to focus on is just this part right here, just the inside part. Okay, I'm not going to worry about the other numbers, just do that. That's where you always should start, is worry about phase shift and period change. Okay, okay, so let's do this. All right, so the period is 2 pi over b. B is 1/2, so that would be 2 pi divided by 1/2. So that's 2 pi times 2. So that gives 4 pi. All right, so we're just going to graph through one period on this. Okay, the increment is the period over 4. The period's 4 pi. Divide that by 4, you get pi. Now that's immediately going to tell me that on my x-axis, I just need to count by pi's. So let's go ahead and do that now while we're at it. So we have pi, 2 pi, 3 pi, 4 pi, 5 pi, that's probably good enough. I'm not even going to bother with what's going on down on the other side, I don't think. Okay, we may have to, we'll see. So I'm going to do that. Okay, so here's what you do on this. Now again, this is a cosine. A cosine always starts high at its high point of 1. So when we're doing this graph, let's see, just kind of looking, we have an amplitude of 1/2 down 1. So I think a good way to do this is probably going to be like this. Just probably make this, let's see, let's kind of go something like this. Let's go 1, 2, 3, 4, and call that 1, and then 1, 2, 3, 4, and call that -1. And then that'll probably be good enough. And then this would be like 1/2. That would be like -1/2. If you extended that down further, then you would end up with -1.5 like that. So, okay, here's what you do. Real simple, okay? These are the key points. I can't stress this enough. Okay, these are, since the cosine is an x value, these things end up being the y value of the graph. So we're used to a cosine starting here. That's where we're used to it starting. However, we're going to phase shift that original point over 2 pi so that maximum hits there. So start at the phase shift, like that. Now remember, we're not doing the amplitude and down 1 yet. We're just doing this in 2 stages. So right now we're totally focused on cosine 1/2 x minus 2 pi. Okay, so it goes like this. Now see, if you know the pattern, then the next one is going to go down to the x-axis. Then the next one's going to go down to the minimum. Then back to the x-axis, and I'll just sort of cycle through these points like that, and that gives me 5 key points. But the key thing is, I took that original cosine point, and I did the phase shift to the right 2 pi. So that is the graph of that right there. Okay, and that's real key. All right. So now we're going to tie in the 1/2 and the -1. So it's real simple. So the second thing we're going to do is we're going to do 1/2 times the y value minus 1. And we're going to do that for all of these y values that are on the graph we just did. Okay, so I'll zoom out on this a little bit and get this put together. So I have y equals 1/2 times something minus 1. Do this for the 5 key points that we just plotted. Okay, so look at these things right here. Again, I'm going to highlight these. You want to focus totally on those y values. And if you've been catching on, we've been using those same y values. Okay, so it's going to be like 1. Whoops, yeah, let's start at this point. Let's start with this point right here. Okay, so that y value, God, come on. Okay, so that y value is 0 here. Okay, and then the next one is 1, then 0, then -1, then 0. So again, I'm just taking those y values of those 5 key points. Work out the details. This is -1. This is 1/2 minus 1, so it's -1/2. That's 0 minus 1, so that's -1. This is -1/2 minus 1, so that's -1.5. And then this one is 0 minus 1, so it's -1. So actually, that gives you your points, and then we're done. Okay, well, that'll show you how these points get changed. Okay. Okay, let me pick a color. Purple, why not? Okay, so we're going to do this. So the first point moves down to -1. Second point moves down to -1/2. Third point moves down to -1. And then the next point moves down to -1.5. And then the next one moves down to -1. So that would be your 5 key points, like that. Okay. So that's, see, and notice what that's done is it's changed the amplitude and it's moved everything down 1. That's it. Piece of cake. Okay. And just one other thing real quick. Let's do one check. Okay, let's check pi. And again, plug into the entire function. So the function is 1/2 cosine. I'm going to go all the way back to the beginning. 1/2 pi minus 1. And take your pick as to which point you want to do. So that would be 1/2 cosine. This would be pi over 2 minus pi minus 1. That would be 1/2 cosine of -pi over 2 minus 1. Cosine of -pi over 2 on the unit circle is 0. So that's 1/2 cosine 0 minus 1. So it's 1/2 times 1 minus 1. So it's 1/2 minus 1. So it's -1/2. Did I do that right? I was doing that so dang fast. I may not have been paying attention there. Yeah, okay, I did something really stupid. Okay, so let me fix this. This thing is driving me crazy. Okay, so the cosine of -pi over 2 is 0. So you just have 1/2 times 0 minus 1. That's -1. Okay, well, that matches what we did there. Okay, so that's it. Okay, so let's see if you can do this now. So pause if you need to get this down. Go to the next page, try this problem, and then that'll wrap this piece up here. So I'm going to pause here. Give it your best shot. See how you do. Okay, so this is what you should have come up with. I'll talk through it real quick, see how you did. So let's see. First of all, this is your factored form. So you're pulling the 4 out. And then to figure out that pi over 8, you're taking pi over 2 divided by 4. So it's pi over 2 times a fourth. That gives pi over 8. So you have your factored form. The period would be 2 pi over 4. There's your b value. So that's pi over 2. The increment is the pi over 2, the period, times a fourth. So that's pi over 8. And then the phase shift is that number there. Okay, so here's what I did on this. Remember, we're doing a cosine again. So a cosine starts at a high point, a basic cosine would start there. And then it would cycle through these points kind of like this. Okay, I'm just kind of showing you where they cycle. Well, I phase shift everything pi over 8 to the right. Okay, so that moves there, and then I cycle through here. That is actually the graph of this part that I have in red. That's the graph of y equals cosine 4x minus pi over 8. That's what I did. Then I take those y values, which are 1, 0, negative 1, 0, 1. Then I multiply by negative 2 and add 1. That gives me the amplitude, the reflection, and the vertical translation. When I do the arithmetic, I end up getting these y values. So negative 1, 1, 3, 1, negative 1. Okay, you can check a couple of points if you want to, and that is it. Okay, so it takes practice, but we've kind of gone from a more time-consuming method now to a pretty quick way to learn how to do these graphs. Okay, if it's a cosine, you start high at 0, 1 and then phase shift it. If it's a sine, you start at 0, 0 and phase shift that. That's the difference between the two. Okay, that'll wrap this up then. Good luck.